Alright, I plugged my iPad in, so we got life. Let's go ahead and finish up these problems. 5. Write as a single fraction, completely factor the numerator and denominator, and state the domain. So, let's see what we can do. Let's look at A. We want to write this as a single fraction, which means we need a common denominator. Now, before we start going all crazy, we should factor everything that we can factor. Honestly, you should pretty much always factor things when you can. Factoring will shed light onto the behavior of a function that you would not be able to see if it was in standard form. So let's factor this denominator, x squared minus 9, difference of squares, x plus 3, x minus 3. That is enlightening because now if I want to find a common denominator so that I can add these things together, let's just change the color because that's hard to see. So I'm going to add these two fractions. If I want a common denominator, look, they both already have a factor of x plus 3, which means to make the denominator common, all I need is for this right fraction to also have a factor of x minus 3, which means I need an x minus 3 in the top and the bottom. So there we have that. Now that we have a common denominator, I can combine them. So x plus 3 times x minus 3, that is my common denominator. That is all under what I have in the top, which is a negative x plus a 1 times x minus 3. So plus an x with a minus 3. So let's simplify this. Negative x plus x is 0. So I get just a negative 3 on the top and an x plus 3, x minus 3 on the bottom. So what else do we do? Write as a single fraction. We've done it. Completely factor it. We've done it. State the domain. Okay, so domain is going to be x is in the set of all real numbers such that x is not equal to negative 3 and x is not equal to positive 3 because of those two vertical asymptotes. So I've done it and I'm finished.